Okay, now something else we'd be able to do is to find angles that are symmetric to a certain angle, and then also to find if we've got a ratio for that angle. So in this case, we're dealing with 20 degrees, and we've got to be able to find tan of 20. We're after another angle that'll be the same as tan of 20. So basically, if we're looking at angles that are symmetric to anything, what we're looking at is that is whatever that is. So in this case it's 20. We're looking at plus or minus 20 degrees from the x-axis. So if we look at 20, we're going to go, that's our 20. Now the other place where it's 20 degrees from the x-axis is over here. So this is 20, and the overall angle here ends up being 160. As well as that, there's another one here, which can also be 20 degrees, and that angle is actually 200. The other spot we can go at is out here, and as we know, if we go all the way around, we end up with 340. So symmetrical to 20 ends up then being, we'll put down 20, as well as that there is 160, there's all degrees, then there's 200, and then there's 340. That's because between the x-axis and all of these angles is 20 degrees. So now, based on that, we want to find where we're equivalent to tan of 20. Now, we know that tan of 20 is positive. So, based on that, we've got to work out which other ones here, which of these other values, whether it's 160, 200, or 340, are going to be positive. So we've got to base it our quadrant. So we know that 160 is in the second quadrant, 200 is the third, and 340 is the fourth. And this, of course, is our first. So we've got to ask ourselves, whereabouts is tan positive? Well, we've got all stations to Craigieburn. It's got to be in the third quadrant, so therefore 200. So we say that tan of 20 degrees is equal to tan of 200 degrees. So that's how we go about using symmetry to find equivalent angles.